On behalf of Quasar Energy, it is my pleasure to introduce technology with the potential to dramatically increase the North American production of economically recoverable hydrocarbons. Heavy oils, tar sands, and highly viscous petroleum require heat to enable their movement through an earthen formation so they can be extracted. Heat can gasify hydrocarbons and coal and convert organic matter known as kerogen into a gas or liquid. The problem with thermal conduction in an earthen formation is its very slow rate of heat transfer. Furthermore, steam loses its effectiveness the deeper it's applied, and at 5,000 feet of depth, the steam turns to water. Radio frequency heating, just like a microwave oven, is a form of dielectric heating. However, the microwave spectrum is not practical for in situ heating due to the extremely short penetration distances of microwaves. On the other hand, the radio frequency spectrum is much more conducive to oil extraction because their wavelengths are significantly longer, which translates into long penetration distances of the earthen formation. Quasar Energy has teamed up with a Rocky Mountain-based energy company that has 19,000 acres containing over 2 billion barrels of oil and tar sands that requires heat to mobilize the oil. This shallow Utah tar sand deposit has been core drilled and fully characterized at a cost of several $1 million. And it is perfectly suited for RF in situ heat because it is oil wet and water dry. Since the RF in situ heat technology initially needs to be developed for a specific reservoir, Phase 1 will be devoted to development and demonstration of the technology at this site. Phase 2 provides for the installation of a 1,000 barrel per day production facility, and the objective of Phase 3 is 10,000 barrels per day. The goal of Phase 4 is 100,000 barrels per day, a production volume this property can sustain for at least 15 years at a 25% rate of recovery. Quasar Energy intends to make money with its RF in situ heat technology the old-fashioned way: produce oil and gas. Since our purpose in life is to produce oil and gas, we have a long-term approach to this venture. But to respect the desire of VCs to have an exit strategy, we propose a scenario that will give them a highly profitable exit by the 7th year, which correlates with the production rate of 10,000 barrels per day. We also welcome investors that are interested in long-term oil and gas production who can fund and provide resources to our ultimate goal of producing 100,000 barrels per day. A geophysicist who has studied the Bakken Shale Formation in North Dakota told me that the in-place reservoir estimate is based on only 40% of the kerogen having been naturally converted to oil. If all of the kerogen in the 100-foot seam were converted, it would increase in-place oil by 76 million barrels per square mile and increase the porosity from 5% to 12%. So not only would the amount of oil be dramatically increased, but the ability to extract the oil would be significantly improved. Once an economical method of applying in situ heat is developed, the first step of future oil production would likely be the conversion of organic matter to a gas or liquid. There is a bill in Congress that will prohibit or severely restrict hydraulic fracturing fluids. So an environmentally friendly green oil technology may soon be desperately needed by the U.S. oil and gas industry. The last known in situ radio frequency heating field tests were conducted back in the early 1980s. These early field tests were successful, even though they were using technology that is considered antiquated by today's standards. Although several major companies were aggressively pursuing RF in situ heating, all research ended when oil prices plummeted in the mid-1980s. The Electrotechnology Applications Center, Bethlehem, Pennsylvania, conducted radio frequency heating laboratory tests on tar sands with spectacular results. The temperature of the tar sands was increased by 800 degrees Fahrenheit in only 8 hours. The team is well qualified for success, consisting of experienced oilmen, expertise in dielectric characterization, and radio frequency technology. The experienced staff of the Rocky Mountain-based energy company is very capable of administering venture finances as well as managing oil production, operations, and marketing of the oil and gas. The aspect we are lacking and hoping that a VC can bring to the team is finance of new energy technology ventures. The 4 patents issued to Quasar Energy are for automatic impedance matching, computer controls, and variable frequency that provide real-time optimization of energy transfer and system automation. These features are crucial because the dielectric properties of hydrocarbons can rapidly change during the heating process. The 2 billion barrel Utah tar sand deposit is only the tip of the iceberg of the boundless opportunities for in situ RF heat that will produce an excellent return on investment. If you would like to learn more about the wide spectrum of energy opportunities using RF in situ heating technology, then we invite you to our booth number 103 for further discussions. Thank you.